We have moved into chapter 3, and chapter 3 is going to be another one that it just feels kind of short. So make sure that you keep up with the homework as we go through chapter 3. You don't want to fall behind because before you know it, bam, we'll be taking another test. And in section 3.1, we have solving systems using tables and graphs. Our objective is to solve a linear system using a graph or a table. And so the first question would be, what do they mean by system? And when you have a system, you have two or more lines. So we want to see, where do they hit each other? I mean, that's where the answer is. It's the intersection. So main objective, solve a linear system using a graph or table. We're going to take a couple of days with this one so we become really good at it. And let me show you here a problem that would be something that we could use this for. It says there are 25 bikes and trikes at the park. So altogether, when you add the bikes and the trikes together, you get 25. The bikes and trikes have 60 wheels in all. So then you start thinking, okay, bikes have 2 wheels, trikes have 3 wheels. In the graph, the red dots show sums of 25. So this is 25 all together, whether or not it's a bicycle or a tricycle. And in the blue, we see the blue dots show all of the 60 wheel combinations. So they told us that they have 60 wheels, and they're giving us the combinations that would give us that. But here's what has to happen. Both have to happen at once in order for us to find the answer. So like it says, how many bikes and trikes are in the park? Explain. We could just continue these lines, and we probably have to add some more graph over there to the right a little bit. But then we could see, where do they intersect? Now, in the next few sections, we're going to learn how to do this algebraically. But like I said, I just wanted to show you this is one of the problems that we could use that we'd be able to solve using our thoughts about linear systems. I keep thinking too, there's all kinds of riddles about bird watchers and bird lovers have taken their birds to the park, and the dog lovers happen to be there at the same time, and they all brought their dogs, and then they tell you how many feet, how many paws, how many feet there are at one time. Sorry. They tell you how many there are, and you're supposed to figure out how many birds and how many dogs came to the park at once. So there are all kinds of math riddles that use this type of thinking. Now, problem 1 is asking us, what is the solution of the system? So I'm looking over here, and unfortunately, this little 8 and negative 8 didn't show up really well there. And I realize, oh, they went ahead and graphed it for me. Now, let's just say that they didn't. Negative 3x plus 2y equals 8. I could use the zeros of the thumb method to figure out where I should be graphing that. So if the x is 0, then you cover that up, the negative 3x, and we'll say 2y equals 8. So 0, 4, definitely a point on that graph. And then if y is 0, as in this case, you would cover up the 2y with your hand, and you would see that you're going to have to divide by the negative 3, and that would give you negative 8/3 or negative 2 2/3. Now, you can see in the graph up there that they're showing us a different part of the graph, and I know that because 0, 4 would be up here somewhere, and so they didn't go up that high. They're showing us the part of the graph that we need. And then I switch to the blue, which is x plus 2y equals negative 8. And again, this can be found very quickly by finding the zeros, which are the x and y intercepts. So if x is 0, I would cover up the x, and it will say 2y equals negative 8, so that's 0, negative 4. And then if I put a 0 in for the y, then I cover up the 2y, and it says x equals negative 8. Now that one, I think we can actually make out those two intercepts right here, and we can see those. But it says use the graph of the system as it is. Where is the solution? Well, for goodness sake, they flat out gave it to us. Look at it. It's in the purple up there. And in the purple, we see the ordered pair, negative 4, negative 2. So what does that mean? That means that the ordered pair -4 and -2 is in both of those lines at the same time at the exact same place. If we wanted to check it, we could put -4 in for x and y in for -2, and it had better work in both of those lines, or we have not found the answer. It must work in all the lines in the system, and there were only 2 in this system. So the big question here is, how are we going to know it when we see it? Where is the solution of any system? And it is at the point or points where the graphs of the equations meet or intersect. So where the graphs meet. That's what we're looking for. Now, we all know that sometimes the graphs don't meet because they're parallel, so we have to put no real solution. We also know that it could be the same line graphed right on top of itself, and that would be infinitely many solutions because they're always intersecting. But more often than not, most of our problems are going to have one point where the graphs meet. So this is where we have a point on one line that is also a point on the other line, and those are where we see our solution. So method 2 says, how about if we use a table to figure out where these two hit each other? Well, to do that, we have to put these into, you can see up the side here, slope-intercept form. And that's because our graphing calculator only takes y equals when we put these in. So for this one, which I'm going to do in red, -3x plus 2y equals 8, I'm going to add 3x to both sides, thinking about that y equals mx plus b, divide everything by 2, y equals 3/2 x plus 4, so that one's ready to go in the calculator. And then I'm going to go over here to x plus 2y equals -8 and do this one in the blue. So I'm going to subtract x from both sides and divide by 2. And there's a little imaginary 1 here, so that will be -1/2 x minus 4. So now I'm looking at these two equations and I'm thinking, okay, they're not the same line. Otherwise, they would be exactly the same. They don't have the same slope, so they're not parallel. They're going to hit each other somewhere. And what I want to know is where. So we will go to our graphing calculator and we will punch those in. And we had y equals 3/2 x plus 4. So parentheses 3 divided by 2, parentheses x. Remember, we're going to put all fractions in as parentheses, and then plus 4. So there's my first line. And my second one is y equals, and that was parentheses -1 divided by 2, parentheses x, minus 4. Enter. So there they are. And now what I would want to do is take a peek at the graph. So I'm going to hit zoom 6, hoping that I can see the intersection in the -10 to 10 window. And I can. It's right there. So if I had to take a guess looking at this, I would say it's maybe -4, -2. But I'm not going to guess. What I'm going to do is I'm going to go and use the table. Second graph. And I want to take a peek at what's going on at -4. So I scroll back and look at that. -2 is on the blue line, -4, -2, and -4, -2 is on the red line. And that was exactly where the solution is. So we would write down the ordered pair, -4, -2. Now that is a way to solve these using tables. However, there's a better, faster, more effective way, especially if they don't come out to be nice integers, if they're fractions or decimals. And that's where we use my pet Blinky. Blinky is my pet cursor, and Blinky is in here to help us. He's totally hypoallergenic. Nobody will ever be allergic to him. So what we do is we hit second trace, and Blinky hides in all of these. So I'm looking at these names and I see intersect and I realize, oh, that's exactly what I want. So I either hit number 5 or I scroll down and I hit enter. And now Blinky is going to ask me some questions. You want to look down here. where Blinky says, is this the first curve? And I see Blinky's on the blue. Sure, we'll call that the first curve. Hit enter. And Blinky says, is this the second one? Yep, I did the blue one first, so the red one is second, and I hit enter. And now comes Blinky's playful side. Take a look at what Blinky says with the little question mark here. Guess. Blinky is asking us if we'd like to take a guess. No, Blinky, I wouldn't be using the calculator if I wanted to take a guess, so I'm going to hit enter. And look at that. Blinky tells us we're right. -4, -2 is where those two lines hit each other. Now, you certainly can use the tables if they ask you to use the tables, but this is something that is much more effective when we end up with the answers that have fractions or decimals in it. And so I would encourage you to call up Blinky under second trace whenever you want to find those intersections. So, back to your note packet, if I can get it back here. Well, that's not it. Okay, so that was interesting. I must have hit a button there that caused that Smart Lab to come up. So we used a table, and we found the answer of -4, -2. And like it says, you can use the tables. One of the things we have to be careful with here is we were doing some statistics in chapter 2. And we want to make sure that our stat plots are turned off. So if you need to, you can go into second, y equals, and hit number 4, plots off. But we should have already had all that cleared out. So we can press table, which is second graph, scroll up and down until we see the exact same y's. So it was -4, -2, because that is where the lines intersected. And that's why I think using that intersection feature with Blinky, it's more logical because we're seeing intersection right there on the screen. You can use the tables if you'd like to, but I would definitely recommend getting used to using Blinky there. So now, the got it says, what is the solution of this system? X minus 2y equals 4 and 3x plus y equals 5. So we want to use our graphing calculator. I'm going to make the top one green. And we'd want to have y equals mx plus b. So we're going to subtract x from both sides. Divide by -2, and be careful because now there's a lot of negatives. So this is like a -1 divided by -2, which is 1/2 x. 4 divided by -2 would be -2. And the bottom one, 3x plus y equals 5. So we would subtract 3x from both sides and get y equals -3x plus 5. And again, we can see we've got a slope in the green one of 1/2, a slope in the blue one of -3. They're not parallel, and we look at the two lines and see, hey, they don't have anything in common, so we need to find out where is that intersection. So we'll go back to the graphing calculator and clear out what we had in there. And then put in this next little set, which was parentheses 1 divided by 2, parentheses x, minus 2, enter. And then the other one was -3x plus 5. Now, if you ever type in something like this and you hit graph and it says you have a syntax error, it's usually because you used subtraction instead of the negative symbol, so be careful with that. If it's in front of the x, it needs to be the negative symbol, which is just to the left of enter. And now I'm going to hit graph because we were using the -10 to 10 window. I would say 2, -1, so second table, and yes, 2, -1 is in the blue, 2, -1 is in the red, but again we could use Blinky, second trace, number 5, enter, enter, enter. And Blinky says, yep, there it is, the ordered pair, 2, -1. So let's write that down. Now we could, of course, graph these by hand. And yes, I mean, we want to be able to do that. But the whole purpose of this is we've gotten really good at graphing by hand. However, if the numbers get really large or they become fractions and decimals, then we're really just kind of guessing where we believe it's gone if we are graphing by hand. We have to make sure we're finding the right solution, and that would mean let's put it in the calculator. So this got it says, what is the solution of the system? And you've learned a good chunk of information here about how to use that calculator at this point. So this is where I'd like you to hit pause, and I would like you to give this problem a try and see if you can find those intersections. All right, so I'm going to go ahead and start here. Hopefully you've started your notes back up by now. And I'm going to make the top equation red. So we would subtract 2x from both sides. Negative y equals negative 2x plus 1. Divide everything by negative 1, and y will be 2x minus 1. Then I will make the bottom equation green. Well, this one is already y equals mx plus b. I'm just going to put the y first. That's pretty cool. So now I look at it and I see, oh yeah, they're two different lines, so I better go punch those in, and I think I'm going to pause it this time while I punch these in so you don't have to wait for me. There they are, already in, and I will hit graph. Negative 1, and it looks like a little lower than negative 2. So this is why I'm encouraging you to look at what's going on with Blinky. I want you to go ahead and look at this table and see if the y sub 1 and y sub 2 actually are at the exact same spot for any of this. And we see that it's not. So this is why it would be really good to use Blinky. Second, trace. Number 5, that's the first one, hit enter. That's the second one, hit enter. We don't want to take a guess, hit enter. Now, we should recognize those decimals as fractions. 0.66666 repeating, and then of course it put a 7 in there because it's rounding. That's 2/3. Negative 2.33333 is negative 2 1/3. But if we change that to an improper fraction, we would take 3 times 2, which is 6, plus 1, so this is multiplication and this is addition, and get negative 7/3, which of course is negative 2 1/3. So our correct and perfect solution would be 2/3, negative 7/3 for our ordered pair. So like I said, the table is good if they come out perfect as integers, but they don't always come out perfect as integers. So Blinky, second, trace, and away you go. And here's another reason that we should use the calculator, and that's going to be whenever we have nasty decimals, huge numbers. This is talking about sharks, for goodness sake. And it says the diagrams show the birth lengths and growth rates of 2 species of shark. If the growth rates stay the same, at what age would a spiny dogfish and a Greenland shark be the same length? Now, there's actually been evidence that's been collected that says that those Greenland sharks are making their way into towards the Great Lakes. They're not there yet, but they have actually found one in New York, and it's just one of those things where they can adapt over time from saltwater to freshwater, and that just scares me to no end. So Greenland shark right there always makes me think of that. Now, they're giving us the growth rate and the birth length. So what they're really doing is they're saying these sharks will start off at 37 centimeters, but they're growing, and that growth rate is the slope. So that's going to be, I didn't leave myself enough room there, 0.75x plus 37. So use the information that's in the orange and write an equation for the spiny dogfish shark, please. That one would be y equals 1.5x plus 22. So what we should notice here is the Greenland shark starts off bigger. We've got the 37 centimeters versus the 22. But that the spiny dogfish shark is growing faster. So 0.75 for the Greenland shark, 1.5 centimeters for the spiny dogfish. And now we'd want to put that into the calculator. So I'm going to stop this and punch it in. So I have those two equations in, and now here comes the really important part. We're no longer talking about numbers from -10 to 10. And what we have up there, our x, was talking about what they grow per year. So you can't have a negative year. We better go into window. And in window, we'll start with 0 years old, which we already know how big they were. They were 22 and 37 centimeters. But we want to know when do they meet. So unfortunately, some sharks can live to be well over 100 years old. So I'm going to try 100 for my maximum x, and I'm going by ones, so x scale is fine. But my y's in this one were the size, and that was in centimeters. And remember, the spiny dogfish started at 22 and the Greenland shark started at 37, and they're both just going to get bigger. So I'm going to try 0 to 100 for that as well. I'm not changing any of the other settings, and then I'm going to hit graph. And there it is. That's the spot where they are the same size. So I need to do second trace, number 5, enter, enter, enter. And Blinky says 20 years, 52 centimeters. So the ordered pair 2052 is where they are intersecting. But we don't write answers to word problems as ordered pairs. So that's why I made a point of saying at 20 years, they will both be 52 centimeters in length. Should make it readable and understandable. So 20 years old, those two will be the same size. All right, next up. If the growth rates continue, how long will each shark be when it's 25 years old? That's a really good question for the table, because the table will tell us 25 as an x, what's that for y sub 1 and y sub 2? So every once in a while you get a problem where the table is a really good idea. So we'll go back and hit second graph into the table, and then we can just scroll down to 25. It's not that far. All right, so our 25 had the Greenland shark at 55.75 and the spiny dogfish at 59.5. So this is what we saw in the table. But again, for part A, we would want to write out what each of these is. So Greenland shark, 55.75 centimeters, and spiny, oh, my S didn't take, spiny dogfish shark, 59.5 centimeters. So we have those two. And we could have just used the equations that we wrote and put a 25 in for x into both of those. But again, we're trying to use more of the technology. Now, B here says, explain why growth rates for these sharks may not continue indefinitely. So I need you to think for a little bit about what might happen with those sharks so that these are not forever equations. A couple of things come to mind, right? First of all, they may die. stuff happens. You get caught in a net. Some parts of the world, still fish for sharks, all that kind of stuff. And the other is they stop growing. They are a biological, and just like people eventually stop growing tallness-wise, unless you have some kind of deformity, the sharks are going to stop growing as well, which is good news. I really feel that's excellent news that sharks will stop growing. They're big and scary enough. We don't need to have them keep going for their entire lives. So that is using our graphs to find the solutions. Now on a test, even if you use your graphing calculator to graph it, you have to be able to put it onto the paper for us so that we can grade you on what you've done. So don't give up on your graphing by hand skills, but we do want to, for accuracy and definitely for problems involving decimals and fractions and those types of things, get used to using the graphing calculator. So there is the 3-1 day 1 assignment, and obviously there will be some graphing.